Correct.
Morning, all.
Morning.
Everybody had a great weekend.
Seemed longer for some reason.
What's that again?
It seemed longer. Of course, when you go from Wednesday to Monday, that's a long time.
It seemed like it went to me.
Well, you stay busy, that's why. Much to do.
This has been a rough weekend for me. I don't know if that shot has affected me or the combination of the shot and the weather, but my arthritis, man, it has done me in. Let me tell you what, I have hurt everything, even down to my little pinky hurts.
Did they warn you about any side effects?
No, not really. They just, they said to make sure that you document all your side effects so that we can put it down. I've heard, different things. Like I say, I got the shot on, what day did I get the shot on? Thursday? Yeah, I got it on Thursday. And I don't know, Friday morning, I woke up and I went to class, and by noon, class started at 9, and by noon, I was using my walker, and I've used my walker all weekend.
You getting old, Eric.
Yep. It's not the age, it's the mileage.
I know.
Okay, so
Are you gonna go with the test?
what's that?
You gonna go with the test? I hope so.
Not yet. I will on Wednesday.
Okay. Yeah. There.
Two people have failed to take it yet, so I'm going to let them.
Oh,
So that's why I don't want to go over it. However,
okay.
I do want to say one thing about the test. Because we had so many presentations that were relatively close. Basically, when I made the test, I went back and I watched each one of these, and I pulled out things that you said in there. So, like for instance, one of the questions was this particular type of building method may not be good in a wet environment. Well, there's a lot that may not be good in a wet environment. However, in the presentation, one person said that about theirs. They didn't, the other, I went back and I checked, the other ones, say for instance, Adobe, Charles, that one may not be good in a wet environment. Straw bale may not be good in a wet environment.
Yeah, Mark. Oh.
And so I made sure that I didn't put, if say Brian said that it was not good in a wet environment and Charles didn't, then it was applied to the straw homes rather than the Adobe. Now, Mark, yours and
Which Mark were you going?
both Marks.
Okay.
Both Marks were very similar. So I've got to go back and hand grade everybody's as well, because those were very fine lines. So I wanted to make sure that you get credit for those. On the matching especially, it's kind of hard for me to say earth sheltering versus underground. So if you guys said one of the two, that I'm counting it regardless. But now if you come up with something completely, totally different, like cordwood or something, then
Yeah.
But does that make sense?
Well, yeah, that one in moist environment, I naturally put straw bale. I mean, I didn't go back and watch all those videos. I just did everything off the internet and got it as logical.
Supposed to be taking notes.
I did, but the internet's supposed to be accurate too,
Oh yeah, they wouldn't put anything on the internet if it wasn't true.
That's right. It's all truthful.
I think Abraham Lincoln said that.
That's a good one.
Kudos, I like that one. Yeah.
Abraham Lincoln said everything. So did Mark Twain.
Oh goodness. Oh man. Okay, so we are back into our last little building envelope thing, talking about moisture. So to start off with, I want to talk about a couple of different types of moisture that enter your house. And we have liquid moisture and we have vapor moisture, and both are detrimental to a house. So, you know, here we've got, we're building a structure that houses people, and I'm finding this out even more tremendously with this bus. You know, I thought I had this moisture thing down to a science, you know, in a house, but now all of a sudden we're talking about a thin metal wall versus a thick wall, and everything just goes to pot. And, you know, a house doesn't rust necessarily, but the bus will. So, all right, so the bulk moisture transfer. So bulk moisture transfer can be any number of these things. And it doesn't necessarily have to relate to weather. All right, so it can be plumbing leaks. You know, it could be, and I guess this would be back to a plumbing leak. We put down hardwood flooring in our house. And before we finished all of the hardwood flooring, our washing machine decided that it wasn't going to cut off its cold water. So it filled up and filled up and we started to load the laundry, and then me and my wife, we used to walk across the mountain. It took about 45 minutes. And by the time we got back, we had an inch of water all over the first floor. So that was a bulk moisture transfer. But it was, you know, it wasn't necessarily a leak, but it was an appliance mouth. So, you know, obviously rain, you know, a lot of people think, well, rain and wind driven rain. So, you know, we worry about rain especially. And I'm going to tell you, rain will reach out and touch you in places that you were not always aware of. As soon as my drawing palette comes up here and doesn't freeze up.
Hey, quick question on the tech. Is there a way to expand the PowerPoint to full screen? Like, I don't need to see images, but I can't remember how I did it.
The PowerPoint full screen, yeah, just go right down here at the bottom. Slideshow.
I mean, from your, like, it's showing the images, I mean, our faces. There's a way to like full screen what you're showing us on the share and just don't look at. I did it once, but I don't remember how the hell I did it.
I don't know. Look, the only thing I would know was to look in your control bar. Do you have a control bar?
No, only the host has one.
Oh, okay.
I mean, I got the basic stuff at the bottom, yeah, but there's no.
I don't know.
Let me look under video.
Well, for some reason, my white pad's not working. Let me see if it's plugged in.
Video.
Pads play havoc with my instruments at times.
Ooh, that don't look good.
Well, it's still not working here. I've got a little pad here that I use and a little pen, and I come in here the other day and it was dangling off of my desk. I don't see a power button. It just comes right on, but it's not working for me. Well, that just messes up. Let's see if I can do it with my mouse. No, I can't do it with my mouse. Well, shit. This is great. Okay, so I'm gonna have to go find pictures. Okay, so let's take, for instance, this little house here. So we have a metal roof on it, or we have shingles, or we have wooden shakes. So let's look at a wooden shake, and these are always nice to use.
That helped.
All right, so true cedar shakes, you know, much like this here, you see all these gaps in here. Well, in my little cabin out here, I can go inside of that and I can look up and I can see daylight. But because of the way that these things are made, you can see these lines that are in there, and that's just the normal grain of the wood. So rain, you know, sticks to this by means of surface tension. And because we don't have these joints here lined up, then, you know, rain comes off of this, falls down into this crack, but because this one goes up underneath it, then it continues to run down. Now, let's add hurricane force winds into it. Now, all of a sudden, the rain is coming in from the sides or maybe upward because we've got that spin going on as the wind comes across this roof. Then we have upward wind that's blowing water back up through it. Then we can get massive leaks in this type of roof due to the wind. So that's what I mean by wind-driven rain. Rain generally falls straight down. Wind-driven rain can fall anywhere. Now, another type of roof that plays havoc sometimes is a metal roof. And you think, well, a metal roof, that there shouldn't be a problem with metal roofs. And so let's look at this metal roof. So this is a typical way of metal roofs being installed. You have a ridge piece that goes on top of there, or a hip flashing that goes on top of there. And, you know, again, rain falls down, runs off. But if we get wind-driven rain, then of course it's going to go up and through here. Another thing, another downfall with metal roof is when it gets hot. So when it gets super hot and water hits it, it is like that ink quill. I know you guys have used, you know, you've probably played with an ink quill or calligraphy pen. Boy, that's completely dumb. So when you're looking at a calligraphy pen, let's see, tip. So they have a slit going down the middle of them. And a quill is the same thing. A quill is basically a feather, okay? And they cut it in such a way and put a slit in it so that the hollowness of that quill holds ink. So it basically, when you touch the ink, it sucks it up in here. And then when you place it on a dry piece of paper, then the ink transfers to the paper. Well, in this fashion here, where we've got two pieces of metal over top of each other, it works in the very same manner that especially when it's warm. When it's cold, it doesn't wick that up quite so bad. But in the summer, when this thing gets hot and then we get an afternoon thunderstorm, then all of a sudden we've got that cold onto a hot roof. It just sucks it right up in there, and then we have some problems with that. Overhangs can be a problem. What if we don't have good enough overhangs? What if we don't have gutters on our overhangs? Then that could be problematic. Gutters are actually required as far as the code is concerned to a certain extent. So what if we don't have gutters? I don't know how to put this to get the picture to pull up. I wish I could draw it. It's driving me crazy. I can't draw. I'm just going to do this and see what I get. And of course, they're all going to show gutters. Okay, so here's a gutter alternative. So it's not really a gutter as much as it is a diffuser. And so when rain hits that, then it diffuses the rain and tries to push it away from the house. Other ways that we can do that, not that one. Well, another way we can do that is have a French drain on the ground. All right, so we don't put gutters on it. We put this French drain down here and we cover this with stone. Water comes off the house. This is sloped away from the house. And then we have a drain that is going to take it away from the house even greater. So these are alternatives. So if you have an alternative that is acceptable by the code, then of course you can use it. But if you don't, then technically gutters are required to go on a house. Effective flashing. Holy mackerel. Let's talk about chimney flashing. Chimney flashing is probably one of the hardest type of flashings to put on. If it's not put on correctly, then it makes a heck of a mess and the chimney leaks. Even with some of the best methods that I've seen, you go into the attic and you'll see some presence of water in the attic. This is called a cricket. So this is just another way to shed the water away from the chimney, because here's one of the #1 places that they will leak is on the upper side. Obviously, you've got a cup that's going to be holding water there. And to get this water to shed away, then, you know, it's good to put a cricket on here to shed that water away. Now, what about up here? What if the water hits the brick and runs down? Technically, the type of flashings should be inset into the brick. Let me see if I can.
Would caulk work?
What's that?
Would caulk work in that instance or not?
No, not caulk alone. No, does not work. Let's see if I can find a better one. This is driving me crazy, guys. It's like talking without using my hands is I can't draw it. There we go. Okay, let me see if I can blow this up. Okay, this is the proper way. This is not the best picture in the world, but you can get an idea. So you put your step flashing. This piece of flashing down here at the bottom goes in and just up on the wall slightly. Okay. And then you have counter flashing that goes over top of this. You can put some caulk, a bead of caulk in here to keep water from wicking back up. But then the flashing is cut into the brick. And that's why you see this step the way it is, because each one of these, where was I? Each one of these, you'll notice that it is lined up with this joint here. So they're going to bend this, and they're going to have to cut the mortar and stick this into the mortar. Then this one's going to be stuck into the mortar as well. So we basically start at our bottom and work our way up. This doesn't have counter flashing on it, but it should. There should be a counter flashing over top of, or under this, but over top of the shingles. Let's see if I can find another one.
What's code in that regard?
That, I mean, you know, using counter flashing with step flashing and counter flashing is code, and I'm not finding a good picture of it at all. Dang it. Again, it's driving me crazy that I can't. Okay, so the step flashing, if you're using shingles, we're going to put a shingle on, and then we're going to put a piece of flashing over top of that. Then we're going to put a shingle on top of our step flashing, and then we're going to put another step flashing on top of that shingle. So we're going to go shingle, hit the wrong thing there. We're going to go shingle flashing, shingle flashing, shingle flashing, shingle flashing, shingle flashing, shingle flashing, shingle flashing. Then we're going to take the counter flashing, cut into the mortar, and then we're going to start at the bottom, put this one in, caulk it, put this one in, caulk it, put this one in, caulk it, and I keep hitting that stupid thing, and so forth and so forth. So that way we get a perfect good seam up through there so that we don't have any leaks. And, you know, we have to play with the fall of the roof to make sure that this comes down. Now, notice this little thing here. This is bypass flashing. In other words, this goes past the chimney there, and then the top of it is folded down. And if you're really smart, you're going to embed that into the brick as well. But because the flashing does not go in the same direction as the mortar, then sometimes that becomes hard. And counter flashing there at this point could be a problem if not really done correctly. If this pulls way up, then we can put some counter flashing over top of it. We do have a better job. The problem is when water comes down here, and especially, you know, let's say that this chimney is way down here towards the end. So that water has got, you know, it has built up some speed, and then it can roll right up that thing and over top of this top piece of flashing. So if chimneys are down here towards the edge of the roof, rather than up here near the ridge, then this type of flashing needs to be a little bit higher. And of course, the cricket is the best thing for us to use on a low roof chimney.
That looks like copper.
It is. It certainly is. Copper is one of the best methods to use. It's easily mandible. You can actually solder this in place. So you can make waterproof joints on the roof with nothing more than just some MAP gas and some solder. And it does a really good job. We won't talk about the expense. And heaven forbid you ever go on a vacation and somebody go up there and steal that stuff. So, so that gives you an idea about chimneys. Also, we have plumbing vents that come through the roof. And this is probably one of the biggest problems here, is because it has been installed incorrectly, or it's people are not doing maintenance. You know, it really just it just surprises me how people will take so much pride in making sure that their car oil change is changed every 6 months or every 3,000 miles, but they never once get up on their roof. They never once go into their crawl space and do general maintenance. I mean, hell, I can't get my kids to even change out the air conditioning vent or filter once a month. You know, I mean, it's just, anyway.
I've cleaned out more gutters than I care to admit.
Yeah. I mean, gutters are huge problematic if you got trees, and we've got oak trees all over the place, and especially in the springtime we get those oak flowers, those oak tassels, if you've ever seen those, and that's like spaghetti on a roof. So these little tassels, they fall off and they gather on the roof and they will stop up a gutter in a heartbeat. And so you have to get up there and clean those out. And, you know, these things, you can't just take a leaf blower and blow them out. They are like glue in there. You got to scoop it out by hand. That's exactly right. And so, you know, number one, people have a problem. My wife, she gets on the second step of the second rung of a ladder, and, you know, she's shaking because she's scared of heights. God forbid that you get up on a steep roof on a house, especially on the back of the house where you might have a basement and 2 stories. So you're looking down 3 stories, and now you're going to get down on your hands and knees and put your head to the lowest point so that you can dig this crap out of your gutters. I understand that. You know, pay the local kid $20 to get up there and do it for you. He'll do it. So yeah, clean those gutters out, inspect your vent pipes, and, you know, replace this if necessary. This is the school book way of putting this in. There's a big piece of metal that goes way up here all the way around, and so this has to be put on as we are going up the roof. We're going to put this row of shingles on, we're going to put our flashing cap on there, and then we're going to cut these shingles out and go on top of there, and then we're going to cut these out and go on top of there. So, you know, there is a process, and if that process is not done correctly, then it can be a huge problem. Now, how about this? One of the biggest reasons that I've seen for this failure is cutting this hole too small. So when you buy these things, a lot of times they are designed to be used on different size pipe. You know, so they have a ring in here that says 2-inch, 3-inch, so forth. So I've seen people cut it to the 2-inch and then shove it over a 3-inch pipe, thinking that it's going to be a better, tighter seal. Well, it is for maybe 6 months until this rubber starts to give way and it's going to break it, you know, because you've put it under too much stress as to what it's, you know, it's not been intended to. This particular case is probably just dry rot. It's just been up there for so long, and the sun does horrible things to rubber. And so there are tons of different new ways of doing these type of flashings that may last a little bit longer. This is an old way of doing it. This is lead. So it's a two-part thing. So the single part is basically the pipe and the shield here that goes down, and then you have this counter flashing there's just another cylinder that you put over, and then you bend the top of it in so you don't get any leaks around the side of it. I haven't seen this in years. Matter of fact, I haven't seen it sold in a very, very long time. But I've still come across roofs that have this type of lead flashing on it for sure. And so, you know, there's tons of different types of flashing. This type of flashing right here is used for a metal roof because it has a silicon. And another thing too, so these old plastic things, and that's where, you know, basic old rubber. All right, so this is rubber versus silicon. Silicon is a little better. There's another picture of that two-part type that I was telling you about. The vent can, and then the cylinder and the plate. Silicon is, you know, we've come up with, you know, this new type of rubber silicon that lasts quite a bit longer, and obviously it does good for heat because it, you know, we can use it to cook with. But here's an idea of how that works. And I'm talking about this type of molding here. We have that mandible aluminum frame around it that is glued to the silicon from the factory. And then we basically, and I will tell you, out of all of the different products that I have used on roofs, I go down, and you'll think I'm funny, I go down to the auto shop, auto supply house, and I buy RTV sealant. So RTV is designed to make a good gasket when you're putting a water pump on, head gaskets or anything like that. And it's a liquid form, but it withstands tremendous amount of heat. So when I'm doing this, I definitely don't want any leaks coming off that metal, because I can't really overlap that metal like I have these shingles. Okay, I just can't do that. I've got a single piece of metal that's running down through there, and then I have to, you know, put this type of flashing around it. So this is the vent pipe, and then the boot just comes across through there, and you can kind of get an idea. Well, I could cut this to 1.5-inch pipe, or 2-inch pipe, or 3-inch pipe, or 4-inch pipe, and then I again put RTV around this here. And RTV, it will stay relatively flexible over time, and you know, we're talking about maybe 180 degrees. And it's designed to, you know, for cars that's going to get to 250, something like that. So it does a really good job, and I've had good luck with that. Definitely don't want to puddle up stuff. you know, you go crazy with the bituminous material and they think, oh, let's go make, well, what this does is this just makes a bigger headache because you end up puddling water up on the higher side. And the bituminous material, again, it might be a petroleum product, but it is going to deteriorate with UV light, and the slightest crack right there is going to be a problem. One of the things that I'm dealing with this bus is I have these vents, escape hatches is what they're called, in the ceiling, and they're old plastic, not PVC, but I don't know, ABS plastic, I guess it is. And over the years, they've cracked. So, you know, I have went up there with RTV all over the place on these things, and water, if it has the smallest hole, crack, whatever, it is going to seek it out and it is going to leak. So this is probably as big of a problem, if not more so than the chimney, but I have seen probably equal amounts of leaks on both chimney and vent. There's that one again in three pieces that I've showed you. So you've got the plate flashing that you basically put all your RTV or whatever around through here. And then this goes over top of it and protects this. And then this cap goes on top of that so that you have extra protection in there. I actually had a customer ask me one time, what happens if it rains in here? Don't I need to put a rain cap over top of this? And I'm like, no, because you follow this down and it goes straight into your sewer. So you're saying when it rains, it goes into my sewer? Yep. Is that going to fill my sewer up? No. So, you know, it amazes me sometimes that how much people don't know about their houses. So basically, you know, take good measures on protecting your house. And, you know, some of you guys, you know, if you don't want to start a construction company, let's say, there are tons of people out there that will pay you to get up on their roof to clean out their gutters and to check these leaks. And to get on, you know, you could create a company that does general house maintenance, and they pay you all year round like a monthly fee, where you go in their house once a month and change their air conditioner filter. You show up twice a year to change it, to clean out their gutters and to check their roof. You'd be surprised. I mean, you know, we have maintenance schedules for our cars. You can definitely set up a company to do maintenance schedules for houses. And the elderly, and I'm not saying go prey on the elderly, but the elderly they are the type of people that need help. I'm the type of people that need help. I'm stubborn ass, and I'm going to get up on that roof, but I'm finding very quickly that my legs don't work like they used to, my knees especially. And, you know, for me to get up on that roof and try to just to get on my knees this weekend was unbelievable. I mean, to get up was unbelievable. So, you know, people like that like the security of having someone come and check on their house from time to time. So, you know, a home maintenance company would be, you know, good. And I don't know that anybody does that kind of thing, you know, greatly. The handyman, handyman does the general property maintenance and makes a killing. Absolutely. Yeah, I can see that, Trevor. Sure. Drainage. Okay, so this is huge. So, you know, obviously, if we don't do any backfill here and we don't have anything coming up through there, then we're going to have all kinds of drainage problems in there. And bad house drainage. So this is what you're going to have if you have bad house drainage. You're going to have it on the inside of your house. Of course, now this sucks all together in general, but you know, you know, especially living in the mountains, when you've got a house on the side of the hill and you've got, you know, 3 miles of water that's going to be traveling downward towards your house, this could easily be a problem. The deeper you go, the more hydraulic pressure you're going to have. So if you have basements, you could have water just squirting in through your basement walls and stuff. And so this is definitely a huge problem. And so it is, you know, it is code that you're supposed to have your ground sloping away from your house for the first 6 feet. But again, if you're living on the side of Mount Mitchell, it's kind of hard to do that. And so, you know, this is what I'm talking about. And so, you know, let's pull this back. If we have a greater bank there, so be it. But let's pull this back, drain it down, and have a drain in there so that we can get rid of that water as quickly as we can. So these are two, you know, definitely two big problems here. Basement or slabs, outdoor slabs, driveways coming in to a house. I don't know how many times I've seen, especially at the lake. Over at Lake James, we've got, you know, these god awful multi-million-dollar developments in there, and so they have the driveway coming, you know, almost at a 45-degree angle into the house, and then they can't figure out how come the rainwater's coming in their garage. So, you know, drainage is a huge thing, especially on that. So let's talk about driveway drainage. Let's spell it right. Driveway.
Most garages should have a drain right in front of it anyhow.
There you go. That's it right there. Most all should, absolutely. Unless it's going downhill, there needs to be a drain in front of that garage door for sure, to catch all that water and get it out of there. So, you know, that's something that you really need to consider if you're going to have such a thing. And, you know, basically you can go ahead and pour the driveway and then leave this open so that you can come back and do a French drain in there and then put some sort of grate over that. These, you know, these type like that, they're not all that expensive. You get into something that's more like, what did I see it? I just saw it there, like this. You get into something like that, and then, yeah, you're looking at a lot of cost. But these are relatively inexpensive. And so a pipe, you'll notice that there's different, or there's bolts here, and that pretty much lets you know where a segment of the drainage pipe is. So you basically get to this last little piece over here, and it has a round connection on it so that you can connect the drainage pipe to it. So any water comes in here, gets out of there.
Yeah, a lot of times they're put in after the fact because people don't think about it.
They don't think about it. That's exactly right. Yeah. You know, one thing that really needs to be thought of when you're talking about drainage is, where does it go from here? So we think, let's look at this house here. So let's say it's going to rain and we're going to put a drain over here to get water to come out over here. Well, this particular way, it goes into the street. What if, see, this drain's over here. So we end up putting a drain here and the water runs down and into this man's house. All right. So we think about, well, we got to get this water away from our house and off of our property. But if you give it to your neighbor, then you could be in for a lawsuit for sure, because you've created a problem for him. So definitely, you know, think about that. And, you know, downspouts are a huge, huge problem. Those little splash pans, yeah, these things here, that is, well, what's wrong with this picture?
It would flow backwards towards the house, I think, unless it's
Well,
sloped inward.
Yeah, this is put in wrong. This is backwards.
Oh, yeah, that's right. I knew
This
something.
needs to, this is wrong.
I see it now. I didn't catch it.
So yeah, these things are very problematic. There's another one put in the wrong way. You know, I mean, what the heck? This is the way that it should be put in. But again, if you put this down and the ground slopes even the slightest backwards, then there's going to be a problem there. Also, keep in mind that when this house was built, the ground was cut right there, and we poured the footing, we put in our block, and then we put backfill into it. So there's an imaginary line running down through here where this soil over here is relatively undisturbed. So it has set for billions of years and compacted. And this piece of soil right through here is, 10, 15, 30 years old, and it is not compacted. So where does water go? It goes to the least resistant spot or the least dense place. And so we have created a bowl here. And if we don't get this away from the house far enough, then even though that, this water is going to come out, it's going to go right back into the least dense place. So these, again, I say, are very problematic because they're not installed correctly. That would probably be the best way to do, but what's going to happen there? Old Fred's going to run over that thing with the lawnmower.
Are you going to trip?
Allie's going to hit that thing with the lawnmower. This is probably the best way to go because it gets it out away from the house, and then you don't have to run over it with a lawnmower. I've seen tons of these. Well, I've seen a lot of lawnmowers messed up because of these concrete ones. But then I've seen a lot of these shredded by a lawnmower as well.
I've seen a lot of new construction now where they're actually going in the ground and taking it out to the road or 20 feet away or something.
Yeah, that's the way it should be. That's the way it should be. Yep. And according to the code, these have to run to daylight. So they can't go into a holding cistern or anything like that. And so, they have to go, once they're in the ground, they have to run to daylight. Okay, so the next one on our liquid water is capillary action. We've kind of talked about that a little bit, but capillary action is exactly what I was talking about with that metal. You get it with wooden siding. You get it in concrete where, if we don't have a good protection around our foundation, then this can definitely be problematic because the concrete is porous, meaning that is a sponge, it'll soak it up. And so when we've got these foundation walls going into here, it is super important to make sure that we have some sort of bituminous material on here. The code actually says that you're supposed to have 3/8 of parging material on there. Parging is nothing more than Portland cement and sand. 1 part Portland cement, 3 parts sand, and it's smeared on to the block. And then you have a bituminous material that goes on there, but then the drainage board is where most people stop. The code says that, all we have to have is this parging.
That's almost like undecorative stucco, isn't it?
Yeah, that's exactly what it is. And then we have some sort of bituminous coating on here. I think Henry's is probably one of the best on the market. It's also one of the most expensive. You can get them in colors, but then you put that on there. Well, again, there's where the code ends. Okay. So here we still have a wall that has let's just call it, for lack of a better term, we're going to call it, we've rubberized this wall here. Okay, we've made it like the inside of a shower. So where does this water go from there? It can go into the the ground. It can go all the way to the footing. So why not go a step further and put in a drainage mat, or rain drain as it's sometimes called, that goes right on top of that bituminous material there, that actually gives space for water to run. Okay, so without this, we're going to backfill this wall and water's going to hit that. And remember, all of this is less dense than this. So this could actually soak up water. And by the time we get down here to the bottom, we have a lot of hydraulic pressure. And if there's any holes, any cracks along the inside of this here, then it's going to be like the little Dutch boy, and we're going to have shooting water coming out through there. So let's go ahead and give us this drainage, to get down to our foundation drain. So let me back up here just.
Wouldn't the black pipe with the holes in it be a good idea to go all the way around and carry the water away?
That is code. That is code. So this is code. So we've got to put the damp proofing on here, and we've got to put either a wash stone catch basin down here with generally a 4-inch perforated drain pipe. And there's several different pipes out there that you can use. In the old day, it was one of these type of pipes here that was just a PVC pipe. Actually, no, let's go even further back.
Used to be, well, they used clay, I guess, a long time ago, clay pipes.
They did terracotta, concrete and terracotta pipe.
Which crack.
Not even seeing any. Try something right quick. I have them on my house.
What, the plastic or what?
Concrete.
Oh.
Well, it didn't work by that one. Let's see. Drain.
Google's search engine sucks lately.
Well, these are my pictures.
Oh.
I think. I don't recognize any of them, but I think. Go back one other way here. Well, it's not wanting to show. Oh, I'm not back far enough. Elbow. I'm taking a stab here at this, hoping that my cellar is in here. And when I say cellar, I'm talking about this section here that's under what used to be the garage. And I'm not seeing it. I was afraid of that. Nevertheless, so let me go back over here. Put it in a different way. Still not seeing it. Anyway, so what they would do is we had concrete or terracotta pipe. All right. And they were about 12 inches long. And so when we put them in, we laid them in the ground and laid them with a 1/4 inch space between them. So they weren't, technically they weren't right on top of each other. They, I hate it. My pen is not working. This is, I can't talk. I can't teach and not draw. What the hell? So anyway, so these pipes are laid, end to end with a 1/4 inch of space between them to allow water to enter the pipe. So then, then we came up with the new stuff here, the PVC pipe, which had a series of holes cut down one side of it. Now, here's a question. Do the holes go up or down?
Down.
Down. Water, it goes to the least distant space. So we want them down. If we got them up, then this has to fill up to here before water's actually going to go in it. So you have them down, so water goes up into it. Now, the newer pipes that we have like this is, let me get rid of that.
Well, the one on the left is incorrect then. That's what I was looking at.
What you talking about?
The one on the far left, the white one, showing the holes on the top.
Well, that's just a sales thing, and it's actually got 2 holes.
Okay.
All right, so they first come out with this this type of pipe here, which is just corrugated. It's ABS corrugated perforated pipe, which has the holes all the way around it. And so that was good. There was not a problem with that. But then they come up with this, which is a little easier to make, and it has these tiny holes, and it goes all the way around it. Now, notice that green line is on there. What does that green line mean?
This end up?
Exactly. That's exactly it. So that when the building inspector comes and looks at this ditch, he sees that green line, he knows that the proper pipe is up. Now, even though it's showing holes there, it's probably got more holes on the bottom. But that green line is an indicator to the building inspector that, this end up. That's exactly right.
That was a lucky guess.
There must be some fires going on. Yesterday, I don't know if you can hear that, but the Forest Service helicopter flies over our house, and he was out yesterday, and he's been out all day today.
There was a low humidity warning just for that yesterday.
Well, that's, you want to talk about a good fire, man. Back in 1985, April 4th, 1985, Mineral Springs Mountain burnt, and it ran like a son of a gun all the way to Valdez, took out about 28 houses, God knows how many cars. I don't think we lost any life, but anyway. So, all right. So now we're back to code. We've got this foundation damp proofing bituminous material. We've got our drain. We've got our washed stones nose that says no fines. Okay. And then we're protecting that with some sort of fabric. All right. So landscape fabric and so forth like that. And so this is code. That's the end of it. Why not make a nice, good line directly from the top of the earth all the way to this pipe? And that's where that foundation drainage mat comes in, that rain drain, so that we put it on the side of the house to allow water to fly down to this drain down here and be gone, be done. Don't try to capture the water, get rid of the water.
How does that stuff attach?
You see can you see these little, you fasten it to it. You've got metal fasteners that screw into the wall.
You just hang it from the top.
Yeah. I have seen some people put it in as they backfill and just let the backfill hold it up.
Okay.
And I have seen people try to glue it on with but the glue don't work. Glue don't work. Okay. Air leakage. Now, we have talked about air leakage in the past, blower doors, all that kind of thing, and now we're down to the vapor leakage. And so air can bring in a tremendous amount of water. I was trying to think where it's at. In one heating season, there it is. In one heating season, water can diffuse through gypboard at 2/3 of a pint. if you have a 1/2 inch hole anywhere in your house, you can get 50 pints of water diffused vapor into your house. Now, a 1/2 inch hole. So, you know, nobody's going to say, well, we go out there and we see a 1/2 inch hole. 1/2 inch hole is about as big as my finger, right? Well, we got a little crack here. We got a little crack here. We got a little crack over here. We got a nail hole over here. They all add up. All right. So we may have, if we go around our house and look at how many holes and cracks we have, we might have a hole this big in our house. And, you know, a 1/2 inch hole is going to pull in 50 pints of water. Think about how much that's going to let in of vapor. So it's super important to, you know, to go through our house. And that's one of the reasons that we do, a blower door test, is so that we find these leaks and stop them before they bring any extra vapor moisture into the house.
It'd be interesting to have a conversion of the 1/2 inch hole to, like, you know, linear feet, 1/16 inch wide or something like that.
Right. So, you know, air leakage brings in tons of water through many different ways. So through the stacked effect, through wind driven, through turning our fans on, our blowers. So remember those 3 types of airflows in there. And I will post this PowerPoint so you guys can get to it. This is the PowerPoint that was taught to me when I was at App State. So
Show that stacked effect again. How does that work?
The stacked effect?
Yeah.
You missed that out?
I mean, they have to do with natural airflow. Is that it?
It is. It is. All right. So, you know, this is how stacked. What's the temperature of this air?
Very hot.
Very hot. So what the temperature of this air is very cold, and it weighs more than the temperature up here. So it is going to try to push this up and out. All right, just through a natural airflow. There was a really good picture that had, let me see if I can find that right quick, that has, go down to my old files here, Western Piedmont. It's not there. Wait a minute. Oh, that wasn't what I thought it was. Never mind. Not what I thought it was.
Oh.
Oh, we're talking about, okay, so this was the barn at Western Piedmont Community College when I was a teacher there. And this is what I had to deal with all the time. So that's, you know, there was terrible drainage, and most of it was upstairs here. And you can see this was leaks through the metal. So that was definitely a big bulk moisture transfer there going on. And here, so this was the back of the barn. And so there was basically an old hole cut here. And I just had, you know, rivers. So this had been going on so long. What you're looking at here is minerals like a stalactite or stalagmite that had been deposited down here. So that's That's, I mean, this barn was over 100 years old, so. I really just need to get organized on my pictures and get them all together so that I don't have to go through this shit like this every time. Anyway, so we'll forego that. But nevertheless, all right, one more time, doing a crazy search. There we go. That's the picture I was wanting right there. Bingo. All
Oh, yeah.
right, so look at the plastic. Down here, we've got cold air pushing inward. You can see the plastic's trying to be pushed in. Somewhere here in the middle of the building, the plastic is hanging free. And then when you get at the top, you can see that it's puffing out. So there you go. That is stacked effect. That's the best example that I can give you of stacked effect.
Okay, I remember now.
You know, then you go and you put a shaft in the middle of this thing for an elevator. If you've ever been on an elevator, go to the top floor, don't get off, but when the doors open, just step over the threshold there and feel the air pushing up, feel the wind pushing up. Unbelievable. Okay. Continuing on. There's another idea of a rain screen. So this is basically, instead of putting your siding directly on the house wrap or zip system board, you're actually making battens that leave a space. So any type of moisture, whether it be bulk moisture being blowed up under it, whether it be vapors coming up underneath it, has a place to run down to the bottom. Down here at the bottom, basically what you do is you take some screen wire, make a little, you roll it up, make a little circle out of it, and you stuff it up in there to keep any type of insects from getting up in there and making a home. But that's, this is called a rain screen, drain screen. So other type of moisture problems, and this is due to vapor that has condensated on things. And so how does vapor condensate? So let's look at this little thing here. This is called a psychrometric chart. And you can see down here at the bottom, we have the comfort zone for the red. Does my pen work on this? No, my pen don't work on that either. I have to get to take a look at it. So we have the winter comfort zone. And then we have the summer comfort zone. And notice that they overlap. So the ideal temperature that we're trying to keep here, is around 75 degrees. Well, that's too hot for me. I'm down here in the 65 range most of the time. So what does all of this chart mean? So we have our temperatures down here. This is the top row is in Fahrenheit, the bottom one is in Celsius. And then we have the relative humidity, and the relative humidity is running in these circles that or half circles here. So if it's kind of hard to read, but right here we have 10 degrees, 20 degrees, 30, 40, 50, 60, 70, 80, 90. And right here is 100 degrees, or 100% rather, not degrees, 100%.
Are you able to zoom in any on that image or not?
It gets cloudy when I start zooming in.
Sorry, I couldn't see. Guys, somebody smart came up with this chart.
Yep. Well, this is used in air conditioning.
Oh, okay. So it
works closely with what they call the J manual, or which is the scientific way of sizing a house for an air conditioner. It used to be, well, we're going to have a ton for every 400 square feet. Nah, wrong. So because, you know, one house may be, you know, let's say it's, we'll keep it simple. We'll say it's 800 square feet house and it has 2 windows on it and they're both on the south side. And then we've got the other 800 square feet that has 2 windows and those 2 windows are on the north side. So they have to be counted completely, totally different than, you know, so when we're using the J manual, we're counting how many fenestrations we have and, you know, what side of the house are they on? What is the walls made of? And what are the ceilings made of? What are the roofs? You know, just tons and tons of information that go in there to size an air conditioner. So over on this side here, we have what is called wet bulb temperatures. This is a dry bulb temperature. This is what we use every day. I look on the wall over here and it's 46 degrees outside. To do a wet bulb temperature, you have to have a bulb that is on a string and you wet it and you sling it through the air. And it tells you what the temperature is in that way. And it's a little different. I've never done it but once, and so I'm not an expert on telling you how to use it. So let's think about just the temperature. Let's say that we're going to go to the beach. What is the temperature at the hotel at the beach? What is the temperature outside? Somebody give me an idea.
90.
Okay.
90, yeah.
90, whoop, wrong one. 90 degrees. Okay. So inside the room may be a little bit cooler. We'll say it's 85 degrees. Okay, inside the hotel room, because the hotel did not leave the air conditioning on, and that, you know, when the maids come in there and clean your room, they turn that air conditioner off. So you go in there and what's the first thing you do? Damn, it's hot in here. Let's turn the air conditioner on. So you turn the air conditioner on and you set it for, let's say, 70. Okay, so this is our end goal here. I'm gonna make that green. No, I'm not either. It goes away. Let's make it orange. All right, so we go to the beach. We throw everything into the room and we go to the beach. Now, what is the relative humidity at the beach?
Rather high, I would imagine.
Okay, give me a number.
90%.
90%. All right, that's this line going right up through here. Okay, so 90%. All right, so in theory, if we were looking at this, we're going from hot to cold. So that means that we're moving in this direction right here. So by the time we get to 81 degrees, we go back into the room and there's condensation on the door on the inside of our room. The doorknob is condensated. The walls are condensated. We go into the bathroom and the mirror is fogged up. We go and lay down and our sheets are wet. Our pillow is wet. Why? Because we moved this 90 degree air that is 90% humidity down 4 degrees until it hit this imaginary line here, which is called the saturation or dew point. I know you guys have heard the name dew point before, and that's what this is. This is the dew point. So when you hear the you know, let's say for instance that, you know, we get in the weather report right now, it's a sunny 85 degrees, 90% humidity, and you'll hear them say, and the dew point is 81 degrees. So that means that when we move this air, when we make it colder at this point, we just turned it to water. So the other way, why do we get a nosebleed in the wintertime? So the temperature outside is 50 degrees. And we build a fire inside the house and it might be 75 degrees. The relative humidity outside in the wintertime is generally much, much less. Right now, it is 30% humidity at my house. There's 30% humidity. All right, so when our bodies go from an environment of 50 degree, 30% humidity into a 75 degree, our relative humidity here dropped down to about 12, it looks like. And then our nose gets really dry and we get nosebleeds. So that is one way to explain how moisture and air come together. We don't really have to worry about the winter going to the summer, or from the cold going to the hot so much as we do the hot going to the cold. So when we're thinking about that, then we end up getting this condensation on the house. So we have a wall section here. And we have insulation in there. That's not what I want. Sometimes Pinterest gives me a headache. That's all Pinterest. Pinterest. Okay, this is a good picture. Okay, so let's say that we have, this is the outside and it is 90 degrees, 90% humidity. We're at the beach and we've got this down here. We've got it down to about 65, 70 degrees here. As this air moves through this wall, and it will, because we don't want 100% water stoppage here. We put a vapor barrier on it, but we don't want to put plastic on it. We don't want to have a perm rate of 0 because that can be very, very bad for us. However, at some point in here, that temperature, that cold, moist air is going through here, and I'm going the wrong freaking direction. The warm, moist air is trying to penetrate here. Heat goes to cold. So as it goes through this wall and the temperature starts dropping, then the air loses its ability to hold moisture. So, hey, let's just deposit all of that moisture right here on this insulation layer, okay? Or on the inside of the drywall. And that's what I was talking about on the bus. So you've got a wall in a house that's this thick. And in the bus, I have a wall that is, can't see that. Select, all, delete. We have a wall, that is this thick. I have a piece of metal and, about the best I can do is about 1.5 inches of insulation. And then I'm going to have whatever inside material I've got, maybe 1/4 inch. I want to try to keep it lightweight, right? So when the moist air transfers to the inside, then it's going to hit this metal wall here, and that is where I'm going to have condensation. It's going to pile up on the inside of that metal right there and rust the bus. So in a house, we have to concern ourselves with stuff like that because we end up with rot. So above this window here, then we have a tremendous amount of rot right here. Now, what caused this? One of the major causes is people not knowing how to build the house correctly. So in this, we have our header that is over top of the window. This is our window opening. And we have, a double LVL header across through here. over our window. And people have taken house wrap that goes down across the wall. And so if we're looking at the window straight on, they have taken and have cut the house wrap in an X form. Okay. So you know what this means, right? What does that mean right there? What does that symbol mean?
No go.
No go. All right. This is the same thing. No go. Don't do it. Don't cut your house wrap in this fashion. Because what are you going to do with that top flap? So what they do is they just turn that sucker around and nail it to the inside of that header. So now we get condensation on the inside of this that is going to end up collecting down here. So we end up with water. It's going to collect down here. And what does that happen? That's what happens.
How should it?
That's the header over the garage door or over the windows. How bad is it? It's that bad. Completely. I mean, we can take a nail puller and stick in there. It's how bad it is. So what do? You have to tear all of this out. You have to put a new header in it, waterproof it, and then you can finish it up and do a whole nice job. But to repair this, here we're taking all of this house is sitting on top of this header right here. And if we take that out, what's going to happen? We got to support this house while we take this out. It's not like, just jacking up the car and changing the tires. Well, it is, but different jacks. So think about how, if we can't use this, which is, it means don't do it. How do we cut that? We cut it into an upside down martini glass. That way, this is folded around the backside, this is folded around the backside, this is folded down, and there's nothing here but a way for water to get out across the top of this window. That's what we want. We don't want this. We want a drain so that this water will get out of there. We want that water out, out. So we don't have a cup here for this to hold on to. And there you go, upside down Y. Zip board, the zip system eliminates the use of house wrap. It has a special coating on it, which is it's OSB. It's like a plywood, and it eliminates the use of house wrap. But you got all this expensive tape you've got to use, and all of this tape has to be sealed. So you have to roll that tape and push it on there. So, when you're trying to take care of your bulk moistures, your capillary action moistures and so forth, durable sealants and flashing installed continuously so that we don't have any type of rain coming in.
Drain the rain to the plane.
That's right. Air leakages. Get rid of all these air leakages. That way we don't have air bringing in water. Air diffusion. Okay. We've got to somehow control this vapor inside the house. Remember, we breathe. We are 75% water. If we are in a tent with no ventilation, in the morning we wake up and it's a rainforest. Don't touch the tent top because you're going to get soaked. So, venting is a huge thing. So again, don't vent the house. Don't let the house vent itself. put in heat recovery ventilators and exchange that air out. And that goes back to that to the air sealing thing that we were talking about, the ACH, which is the air changes per hour, and knowing how to correctly figure that out. And we go into depth in that in the building science class. When you're talking about vapor barrier materials, then this kind of gives you a perm rating on it. So gypboard is a 38 to 42 perm rating, but then you get down here to that 2-male polyethylene film, you know, it's almost a 0. Craft paper, which is the paper that you see on insulation, is a 1. Okay. And then it tells you, this little chart here also tells you, can it be a vapor retarder? So gypboard is not, latex paint is not a vapor retarder. But then, you know, the oriented strand board, sometimes if it is the zip board, then it can be used as a vapor retarder. Same as house wrap. That goes back to that diffusion amounts going on there. And, you know, again, putting up our insulation correctly. Remember, we talked about not leaving these gaps in here, not leaving holes. You know, if you're going to do a vapor barrier, if you're going to do insulation, you need to be full on. So think about, and this goes back to, you know, I've probably said this 100,000 times. If you're taking a bath, you can't keep this water in if you have a big old hole down here at the bottom. Because if you got a hole down here, you know, all that water is going to run out.
No drain stopper, no bath.
That's right. Same thing goes if we were to turn this 180 degrees. Okay, so instead of thinking of it being water, let's think of it as hot air. If we've got a hole in our insulation, like an attic stairs or a can light or anything like that, then bam, we've lost it all. There's no difference in it whatsoever. If we have a vapor barrier that has a hole in it, then we're just allowing vapors to come in. And living in Western North Carolina, you all know that, you know, it's a rainforest here in the summertime. Our humidity is so high. Polyethylene is not recommended for your vapor barrier. That is the craft paper that I was talking about. It is acceptable. So this technically stops too much. If the summer hot air comes in through our wall somewhere, it's going to hit this plastic, and there's where all the condensation is going to hold, and it's going to be detrimental to our insulation. So here we can get a little bit of dry air, dry warm air into the center of our wall that extracts our moisture and gets rid of it in there. Little chart here that talks about you know, the vapor retarders. Of course, the higher you go, the more moist they are on the East Coast, and then marine. Look at this little line right here. So this is talking about marine down here. It goes back to a number 4, which is just what we've got going on here, because they have so much moisture coming in off of the Pacific Ocean there. I mean, it rains a lot in Seattle and Portland, so you have to deal with that. And then, of course, when you get down here to Florida, then, you know, do we put so the old saying goes, your vapor barriers go on the side of the wall that is heated in summer. Well, in Florida, you don't, you really don't heat a house whole much in Florida. So, it's heated outside all the time. So it's going to generally be hotter. So keep that in mind. LP, the use of LP gas in a house. LP gas is liquid petroleum, and it contains water. Well, it doesn't contain water. It contains oxygen molecules. It contains hydrogen molecules. And when you burn that off, the byproduct is H2O, meaning that you have huge amounts of water being produced when burning LP gas. So if it is not properly vented, this is what's going to happen. This was a house that was in the Statesville area. They lost power due to an ice storm, and the folks ended up using their gas range to heat the house. So they basically just opened the stove up, turned it on, and let it heat up. And it's not made for that. And this was after 4 days of running that oven. 4 days. This is black mold. It is it's Stachybotrys, however you want to call it, but it is 100% deadly. And so this is another one here. And this one, let me change directions here there. And this one here, this is a church down in Louisiana that they had a flood, a hurricane or something came through there, and you can pretty much see where the water line was. And you can't get rid of this stuff. You can't just clean it and it go away. So all of this has to be torn out and rebuilt. So that's pretty bad. So water, saturated materials breed toxic mold. And it doesn't have to be, we have just small moisture problems here, 60% relative humidity and up, then we're going to have problems. These are the health effects. Anybody that's asthmatic, and I have a son that's asthmatic, he can walk into a house that has some mold problems, and it's almost instantaneously he is sneezing, coughing, having a fit, having a hard time breathing. So it's not cool. Even the most healthy person, if breathing this black mold, is going to be super affected by it, and it weakens the immune system. Again, some examples of poor drainage. Okay, we get this downspout draining into here, moisture trying to evaporate up into the house, and we end up with this kind of problem in the basements. This is a vinyl wallpaper used in a bathroom, and so it catches the moisture behind it, creates black mold. This is these darker places that you see here are made before this vent was put into place. So this is what it looked like before the vent. This is what it looked like after this vent was put in place. That gives you an idea of that. Mold growth behind furniture. We can't get, we may have air conditioners going, but the air that flows in and around our furniture may not get moved around enough. And you've heard me talk about all of my fans in my house stay on low all the time. And they are in what is called the winter mode because they pull up and roll around. That way that I get a circulation of air behind my furniture and eliminates this mold growth there. How would you like to breathe this crap? This is a plenum, meaning that we have the main air conditioning being blown through this larger hole. It goes into here and then out through our supply lines. Man, if we get mold growth going in here, then it's kind of like taking somebody that's got COVID-19 and shoving them in there and letting them just breathe into all the rooms. It's terrible. You're sending all these mold spores into other rooms. So preventing that mold growth is immensely important in the construction of the house, because you don't want to have to come back and have to fix these after the fact. You don't want to wait for mold to show up to have to start learning on how to control this mold. So those are, ways to do that right there.
Quick question. On a scale of 1 to 10, how important would you say ceiling fans are in every room to help prevent mold and other issues?
In my way of thinking, it is very important. So if let's say, for instance, that we have a room.
The reason I ask, I preached for 40 years to people that don't even have a tenth of this knowledge, and I've always had ceiling fans wherever I was at, or I'd install them if I had permission. And so many people just would argue with me, and they just, they think it's a waste of electricity.
It's a waste of electricity. That's exactly right.
But it's not. Those motors don't burn that much electricity.
No, especially on low. So, again, we've got here. We may have a couch over here. We got the TV on this wall here. That TV creates heat when it's on. So any type of what am I trying to say? Let's forget about the TV. I'm still going the wrong way. Anyway, so if we didn't have this on, generally we've got a window here. So generally the air conditioning vents are either put in the floor right up under the window, or they're put in the ceiling right up under the window. And so they blow in this direction. All right. And somewhere maybe down the hallway here, we have the return pipe. So air flows in this fashion. Okay, so I keep enough air going on. You see where the racetrack is, right?
Mm-hmm.
So me and Mama sitting over here on the couch, we're not feeling that air. Leroy sitting over here in the corner over here, he's not feeling that air. We could get mold growth growing up behind this chair here, or even behind the TV, because we just have no air movement. By having those fans in there and blowing in towards the ceiling in an up fashion, we're taking this movement of air and we're putting it throughout every gap in this room.
Even distribution.
Even distribution. We are diffusing that air conditioning as it's coming into the fan, and then it's going out to all the places it needs to be. Now, after it rolls around here for a little bit, yeah, it's going to go back down the hallway and into the return. But hopefully by having that fan on, we have hit every little corner and crevice in this, and we have even distribution.
One of the things I've discovered that I've tried to relay to everyone is your electric bill should be extremely lower, because the fan motors are nothing compared to the compressor on the HVAC. If you're not pushing the air, it's got to come on and cycle more frequently, running your bill up. But if you got your fans on, it's pushing the air, doesn't have to run as much, and therefore your bill's lower.
Well, also keep in mind that air conditionings are designed to run 45 minutes per hour. So, 3/4 of the time they are designed to run that long, 45 minutes out of an hour.
Wow.
That's the same.
What about the heat?
Same. 45 per 60. So that's 3/4 of the time that it's supposed to be running, just to move the air. But now by adding the ceiling fans, then this can be reduced.
As low as 15, I found the house I used to stay in Inca had 8 fans, 3 upstairs, 3 up on the upper level, 3 in the middle, 2 in the basement where I was at. And I kept them running all the time till the owner moved back, turned them all off, except where I was in the basement.
Well, the problem is it goes back to that, to that vapor diffusion that we give off as humans, and having the right amount of air changed. even if we put a heat recovery ventilator on the air conditioner, if it does not run enough, then we're not getting the air changes that we need in the house. All we're doing is taking that moisture and just shoving it around the house. We still need to interchange that air more, as much as, as much as required for the size building or the amount of people that we have in the building.
Okay.
Fixing mold problems. So first and foremost, find the moisture source and fix it as fast as you can. Removing the mold as fast as you can. Protecting everybody. Clean with soap and water, then chloride and bleach. And it has been proven since this PowerPoint was made that bleach does not necessarily kill the mold spores. They bleach them. So you're taking black mold and you're making white mold. But once they spore off again, they turn right back black again. So there are special chemicals that have to be used to kill the mold. So don't always rely on bleach as being the kill-all thing, because all it does, well, I mean, it kills some, but it won't kill them all. All it does is bleach them, turns them white.
Would alcohol help evaporate it or remove it?
I don't
I've
know.
had a lot of luck with vinegar.
Vinegar?
Yeah, vinegar. Mhm. So there's some mold resources from the EPA. And like I say, I don't know if this site works or not. This PowerPoint is relatively old. Indoor air quality. So that's, big thing right there. Indoor air quality. We'll be talking about that a little bit more.
Would mold,
Here you go. There's some mold lawyers.
would mold be a cause of influenza?
Could be. Very well could be.
Well, just think what our ancestors put up with and didn't even know.
Well, they didn't, because the house was, and I'm going to use a Appalachian term here, airish. The house was very airish, meaning that it had natural, it had very much natural air movement in the house, in and out. So it wasn't a problem. Okay, that is all.
Do architects get taught this kind of stuff? I mean, it seems like.
Absolutely.
Okay.
Yep. There should be, they've got an architect has to have so many continuing ed credits every year to keep their license. And so, yeah, there's all kinds of different programs that, that talk about mold. It kind of like it's whichever bandwagon people are on at the time. Like, for instance, there was a big thing that, radon gas. Oh, everybody went, ate shit over radon gas for a while, and everybody was protecting themselves. And then it moved on to, well, just lost it. Boom, as my wife says.
Wasn't there carbon monoxide detectors too?
Yeah, that was another kind of fad thing. All of these are good to design by, but they need to be used. Don't just do one thing and think you're safe. Of course, the old saying goes, you can protect yourself so much that you'll kill yourself. So, it's just a thing. You just gotta kind of look at it, and each house is going to be different. Each region is, you guys are different from Asheville it is to Morganton. I don't know that radon gas would be any worse or better in Asheville than it is here, because the fault line runs through Burke County, and we have high concentrations of granite. and Granite is a producer of radon gas. You guys have more wind than we do. You guys experience more colder temperatures than we do. You guys actually have more moisture, rainfall during a year than we do. Not by much, but some, you know, so you're going to have snow more than we do. So like I say, each region, each climate, each county, each portion of the county is going to be different. If you're building a house down near the Catawba River, or in your guys' case, the French Broad River, then you know, you're going to have to deal with capillary action more so than I am, even though that I'm lower elevation than you guys are, but I'm higher up on a mountain. So we have good flow there. So, you know, I talked about the fault line. Look at the rivers that we have around. Catawba River runs to south. The Henry River runs south, but the French Broad runs north. The New River runs north. So what does that mean? That is where that fault line is. So the fault line runs up here. Everything that runs towards the Pacific Ocean, towards the Atlantic Ocean, was on the different Pangaean continent than you guys were. So when I drive from Morganton to Asheville, I'm driving two different ancient continents, and these were the first collide, the first collision during Pangea. So all of your rivers run north to the Mississippi and down, and all of our rivers run to the Atlantic Ocean. Little trivia for you there. Any other questions? As I tell my kids, love to see you
Good
back.
presentation.